Java has come a long way, from Java 8 all the way to Java 23. But as we see in the book, how far has Java come exactly? What exactly has changed? And why is Java still one of the most powerful programming languages out there? We'll go over each of the features that Java has and how it helps you and me become a better programmer in solving problems in Java. So the first thing about Java we need to understand is basically what are the key main features Java has. Java constantly evolves to keep up with modern software development needs. So let's take a quick look at some of the most exciting features from Java 8 to Java 23. Java 8 introduced the Lambda functions, the Streams API, and default methods, as you can see on the screen. Java 9 introduced the modular system and the JShell, which is the interactive REPL system. Java 10 to 11 introduced the var keyword, HTTP client, ZGC garbage collector, so on and so forth. Java 12 to 14 introduced the switch expressions, records, pattern matching. Java 15 to 17 introduced sealed classes, foreign memory API. And Java 18 to 23 introduced virtual threads, string templates, AI enhanced compilation, basically. All of these features help a lot in modern programming, and all of these were created as the need for them developed in the programming community, and Java pulled itself up and met those needs. From better memory management to more expressive syntax, Java has designed itself to make coding easier and applications faster. Now that we understand that, let's go over a little bit more over some of the key important features of Java that you might want to understand and know about. And one of those key features is object-oriented programming in Java. At its core, Java is an object-oriented programming language. That means everything revolves around objects, classes, inheritance, polymorphism, encapsulation, and abstraction. So, as you can see in the screen on the screen right now, we have a piece of code basically, and it shows a Java class structure with objects interacting with that class structure. So we have an overarching class called animal. Basically, that's the overarching object. And in that object, we have subclasses like dog that extends the animal class and adds certain pre-qualifications to that class. Similarly, you can see we have a public main class, but that's just initializing the software. So we have a main class animal and a subclass dog. We can have subclasses like cats, lions, anything basically in the subclasses. So that's basically how the core syntax of how you implement Java object-oriented programming works basically. And the public main class that you can see at the bottom is how basically you initiate the entire software. Object-oriented programming makes Java code reusable and modular and scalable. So whether you need to build a simple app or a complex system, Java's object-oriented programming structure has helped a lot of programming teams to select it as the core language to use in their programming endeavors basically. So now that we understand that, we might want to dive a little bit deeper into basically how the object-oriented programming aspect of Java works, because again, like these are the main features, the main key aspects of Java that you need to understand as we move further along the book and this course. So as you can see here, to work with Java effectively, especially the object-oriented parts of Java, you need to understand the 4 key principles of object-oriented programming in Java: encapsulation, inheritance, polymorphism, and abstraction. As you can see on the screen below, we have breakdowns on the 4 key aspects of object-oriented programming. Encapsulation basically helps us restricts direct access to an object data. What do we mean by that? So certain aspects or certain data is not available or exposed directly to corruption or any sort of access which might lead to corruption basically in certain cases. By corruption, I mean the data being changed to something it should not have been changed in while we're using the data. So encapsulation is that basically in object-oriented programming. Then we have inheritance, which allows one class to inherit from the other. So as you can see in the previous slide, we went over the structure of object-oriented programming in Java. And that structure basically showed us that a main class can have subclasses, right? The main class was animal and the subclass was dog in that. So inheritance basically allows us to have the dog class inherit certain principles, overarching principles from the animal class, and just pre-qualify certain unique aspects of the dog class that are separate from the animal class. Then we have polymorphism, as you can see, which means that objects can take many different forms, basically. And then I wouldn't go in too much detail here right now because we're just covering Java's features here, but we'll be going into much more depth further down in the book and in the course that we're going over. And the last thing is abstraction, which basically hides unnecessary details and shows us only what's needed. So you can have a lot of features within a programming, but abstraction basically means is that you can call a function that does a lot of some sort of activity, basically, very easily. Otherwise, you might have to code all of that out. So abstraction is that you don't even need to know what's happening down there. You can leverage this function and get that done, and that is something that is an important aspect to Java object-oriented programming, and especially here where you only need to see what you need to see and what's needed, not something that it is a sub-activity that is used to get to that particular main logic that you're trying to create. So with that out of the way, we need to understand that you can master object-oriented programming in Java by understanding these 4 principles of Java's object-oriented programming system, and that would mean that you can write more cleaner, more efficient, and more maintainable code. Now we need to focus on the fact that Java is a compiled language. What do we mean by a compiled language, right? It's a compiled language, but Java still has slight difference to a normal compiled language. It doesn't compile directly to machine code, but to bytecode, which runs on the Java virtual machine. So basically, it's a compiled language, but it doesn't directly help you compile code into machine code, but into bytecode, which runs on the Java virtual machine, basically, which acts as the main intermediary for the communication between the computer and your code, and the machine and your code, basically. So as you can see, we have a program here, and that program compiles. That is the program that we write in Java, which is then compiled when we run that into bytecode. And this bytecode goes to the Java virtual machine, which understands what the bytecode means, and then it gives machine executable instructions to your computer to actually work on the program that you wrote. This approach basically ensures that Java code runs fast and securely and efficiently, no matter what platform we use, and makes it much more one of the most versatile and one of the most effective programming platforms that people use, and that was why it is one of the most popular platforms still in programming used today. So now that we understand that, let's move on to another factor to Java code, right? You can write your code once and you can run it on any of the platforms. You are not restricted to some certain version of GUI that you might need to use. Once Java's once you've written code in Java, you can run it anywhere. Thanks to Java's cross platform capabilities, you can run Java on Windows, you can run Java on Mac, you can run Java on Linux. You can develop on any of these systems and deploy it anywhere the JVM exists, and you have JVM compatibility for almost all major GUI platforms or systems that are in the market right now. Let's move on to the next thing, which is automatic memory management. So Java makes memory management very easy. And memory management is a crucial aspect to computer management. So let me put it this way, right? So most people don't understand what we mean by memory management, because some of the higher level languages don't even address that, because it's done on the abstracted away in the background of that language. And so some of the programmers might not even understand what of the high level languages might not understand what memory management is. So your computer has limited space, right? It does not have unlimited memory for saving data and securing it. So when you're writing variables, when you're writing different code, that is executing different processes that requires memory, that requires bandwidth. So memory management is essential for languages like Java, right? And Java makes it easier for you to do that. Basically, with automatic memory management using garbage collection, Java helps you a lot in sorting memory management issues. So basically, as you can see on the screen below, there are 3 important aspects to Java's memory management. We have G1, garbage collector, which is, as you can see here, which prioritizes performance. Related issues in garbage collection. Then we have ZGC here, which is a low latency memory management system. And then we have Shenandoah GC, which handles large heaps of data and does garbage collection efficiently there. This means fewer memory leaks and better performance for your Java applications, basically. And all of that is why, one of the many reasons why Java is used as a very important tool in modern programming. So let's wrap up this concept about different Java features in this video by concluding that basically Java has constantly evolved, and that means that a good programming should constantly evolve as well. So while you're learning Java, understand all of the Java's main features, as well as the fact that how these features could help you code better. Let us know in the comments below. Send us a message if you're following our course and going through our book. And don't forget to like and subscribe for more Java content.